Alrighty. All right, awesome job on Unit 1. We are diving now into Unit 2, which is Systems and Matrices. This unit reviews systems of equations of 2 or 3 variables. Then you will explore how you can use a new tool called matrices to solve these systems. So 2.1 notes, we're doing systems in 2 variables. So we're going to solve systems by graphing, by substitution, and by elimination. All of them today. Yay! So a system of equations is just a set of equations, including one or more variables. The solution to the system is the point that makes each equation true. So it'll be in both equations. So number 1, your school planted 2 trees when it was first opened. One tree, a ficus, was 6 feet tall when it was planted and has grown 2 feet per year. The other tree, an oak, was grown from 3 feet and has grown 3 feet per year. So it says to complete the tables below for the 2 planted trees. So starting with the ficus. The ficus was 6 feet tall when it started out, and it was growing at 2 feet per year. So we're going to add 2 feet after 1 year, add another 2 feet, add another 2 feet, add another 2 feet. For the oak tree, it said it was started from 3 feet, and then it grew 3 feet per year. So we're going to add 3 feet, add 3 feet, add 3 feet. All right, part B says using n for the number of years and h for the height of the tree, write 2 formulas for each of the plants. So starting with the ficus, the height of the ficus was always equal to, notice the rate of growth for every year was 2 feet per year. So we can say 2 feet times the number of years. And then we can add on what we started with for the height of 6. For the oak, go ahead, write the equation. Okay, you should be saying the height of the oak is a rate growth of 3 times the number of years, plus it started out with 3 years. All right, so it says to graph both tables on the axis provided to the right. So the ficus is starting off at year 0 with a height of 6, and then 8, 10, 12, 14, so that's our ficus. The oak tree is starting off at 3 feet, so shorter, but then it's 6 feet, 9 feet, 12 feet, 15 feet, so that will be our oak tree. So it says, when will both types of trees be the same height? So notice it's when the lines cross, and it's also inside your table what point is in both tables. It would be at 3 years, those trees will be the same height. And then it says, how tall will they be? Well, they will be 12 feet. It says, when is the ficus taller? So if you recall, that's the red line here. The ficus is taller from year 0, year 1, year 2, all the way up until year 3. At 3 years, they're the same height. And then when is the oak tree taller? Well, that would be the blue line. Notice it's shorter, 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 and then all of a sudden, after 3 years, it becomes the taller tree. It says, how would this be different if the trees grew at the same rate? Well, if they always grew at the same rate, then that would mean they would never be the same height. Starting off at different heights, growing at the same rate, they would never be the same. And then how would this be different if the tree started at the same height and grew at the same rate? Well, then in that case, they would always be the same height. Okay, we're going to get into the algebraic solving of these now. So there's 3 different ways. We have the graphing way, where you graph both lines, and then where the 2 lines intersect is called the solution. So we write it as a point, 9, 3. The other way is to use substitution. So for example, these both equal y, so you can set the equations equal to each other. Solve for x. Once you know what x is, you plug it back in to solve for y. So notice that's algebraically getting the same answer. And then elimination is when you line up your x and y's together, add the equations to make a variable cancel, and solve for a variable. Once you have this, you can plug it back in to solve for x. So this is called elimination. We're going to do all 3 types. Starting off by graphing. So this is a review of 1.1. Here we go, graphing lines. Starting with the first equation, y equals 2/3 x plus 1. You have a y-intercept of 1, so on the y-axis, put a dot at 1. My slope is rise over run. So rise 2, run 3, put a dot. I could go up 2, right 3 again, put a dot. I could go down 2, left 3, put a dot. But draw on the whole line across the entire coordinate plane because we want to see where these lines are going to cross. Second line is y equals 5. So notice that the y-intercept is 5. We have 0 x's, so the slope is 0. So it's a flat line through y equals 5. So the solution is where those two lines cross, which is at the coordinate 6, 5. Make sure you put it in parentheses. All right, for part B, you have a y-intercept of 1, so starting at 1. The slope is up 1 over 3, up 1 over 3, drawing in that line. Second equation, you have a y-intercept of negative 3. The slope is up 1, right 3, up 1, right 3. So notice these lines are never going to intersect. So in this case, this would have no solution. All right, for C, notice neither of these are in slope-intercept form. So you could do the intercept method, but then you would get a fraction. So notice if you set 0 for y, you get 4x equals 6. That's not going to divide evenly. So instead, I'm going to split these two equations up, and I'm going to solve for y. So starting with this one, to solve for y, I'm going to subtract the 4x term over, so the x's cancel. I have 2y equals. Remember, the x term always goes first, so negative 4x, and then the positive 6, the number by itself, goes at the end. Still need to get y by itself, so I'm going to divide all three terms by 2. The 2's cancel, so I get y equals. It becomes a negative 2x, and then a positive 3. All right, your turn. Go ahead, solve for y in this equation. All right, so hopefully you were able to subtract the 3x over. Then you have to divide everything by negative 3. Remember, a negative divided by a negative makes a positive, and then 9 divided by negative 3 is negative 3. All right, so we're going to go ahead and graph both of these. So starting on the top equation, we have a y-intercept of 3 and a slope of negative 2. That means I'm going to go down 2 and then to the right 1 because it's negative 2 over 1. So down 2 over 1, down 2 over 1, down 2 over 1. Draw on that entire line so we can see where they intersect. For the other equation, our y-intercept is negative 3, and then we have a slope of 1. So that means I'm going up 1 over 1, up 1 over 1, and draw on that entire line. The solution is where the lines cross. So if this is 0, 0, the solution is right 2, down 1. So it's 2, negative 1. For D, same thing. We're going to have to solve for y. So let's split these equations up. Solving for y in this equation, I subtract 2x over. I get 2y equals negative 2x plus 6. Divide everything by 2. I get y equals a negative x plus 3. You try this one. All right, hopefully you just subtracted the x over and getting y by itself. You get y equals negative x plus 3. So let's graph these. We have a y-intercept of 3. The slope is negative 1. That means I'm going down 1, right 1, down 1, right 1, down 1, right 1, drawing in that line. Notice this equation is exactly the same as this one. Y-intercept of 3, and then the slope is negative 1. So those lines are the exact same line. So where do the lines cross? Well, they cross everywhere, right? So this is what we would call infinitely many solutions, or just many solutions for short. You don't want to say all real numbers because notice 0, 0 isn't a solution, but there are infinitely many solutions on that line. All right, number 3, we're going to start by doing substitution now. It is an easy method when you have one of the variables by itself. So notice in the top equation, y is by itself. So I'm going to use substitution. So if y is by itself, I'm going to circle what y equals. And this is going to substitute in for the y in the other equation, since that's what y equals. So if I do that, I get x plus 2. the y is going to go away and it's going to be replaced with 3x plus 2. So x plus 2 times the y goes away, it becomes this whole thing. And then that equals 11. So to solve for x, I have to distribute. So dropping the x down, it'll be plus 6x plus 4 equals 11. Then I have to combine like terms on the left side. X plus 6x makes 7x plus 4 equals 11. Minus the 4 over, I get 7x equals 7. And then divide both sides by 7, I get x equals 1. You're not going to stop there. You have to find both x and y so you can name the solution. So we're going to plug the 1 in up here to solve for y. So we're going circle to circle here. So y equals 3 times x is 1 plus 2. So 3 times 1 is 3 plus 2. 3 plus 2 is 5. You always write your answer as x comma y. So it's 1 comma 5. All right, let's do another one. Notice in this one, the top equation does not have a variable by itself, but the bottom one does. So that's the one we're going to use. So x is by itself. So circle what x equals. This is going to replace or substitute the x in the other equation. So the x is going to go away and it's going to become y plus 3. And then I have plus 2y equals negative 6. I have to combine like terms, so y plus 2y makes 3y, plus 3 equals negative 6. Subtract the 3 over, I get 3y equals negative 9, and divide by 3, I get y equals negative 3. To solve for x, you go circle to circle, plugging this back in. I get x equals, y is negative 3 plus 3. Negative 3 plus 3 is 0. You always write it as x comma y. So it's 0 comma negative 3 in parentheses. All right, for C, notice the variable is not alone on the top. It's the one on the bottom. The one on the bottom, the y is by itself. So circle what y equals. And this is going to substitute the y in the other equation. So that gives me 2x plus. The y is going to go away and become a negative 2x plus 4. And then we're left with equals 6. When we combine like terms, we have a 2x and a negative 2x. Well, that makes 0. That means it's going to go away. So I'm left with 4 equals 6. Except for 4 does not equal 6. When you see this, when it's a not true statement and there's no more variables left, that means this has no solution. That's what this looks like algebraically. Those lines will never cross. All right, now we're going to do the elimination method. So here we go. Notice substitution doesn't make sense because neither of these equations have a variable by itself. But what's nice is the variables are lined up. You have the x's lined up, the y's lined up, and then the equals a number lined up. So for elimination, the goal is to add the equations up so a variable cancels. So when I add these equations up, notice I'm going to get 4x plus a negative 2x, which is 2x. Notice y plus negative y cancels, which means I will be left with one variable. So then this will equal negative 10 plus 14, which is just 4. Notice this is very easy to solve. We just divide by 2. So x equals 2. So it's really nice when the variables are the same number but opposite. So this is a positive 1y, this is a negative 1y. When they're the same number but opposite, the variables will cancel when you add them. Super nice. But notice I also have to solve for y. So I can choose, do I want to plug x into the top equation or the bottom one? Since this one has negatives, I'm going to go to the top equation. So I'm going to get 4 times x is now 2 plus y equals negative 10. 4 times 2 is 8, plus y equals negative 10, minus the 8, y is negative 18. So I write my answer as x, comma, y to negative 18. All right, let's do another one. Notice if I add these equations, I'm going to get 8x plus negative 2y. Wait a minute. neither the x nor the y canceled. So we can't just add them. We have to do an extra step. So I need these to be the same number but opposite. So notice I can't really make the x's the same number but opposite by multiplying one equation, but I can with the y's. I want these to be the same number but opposite. So notice that means I would have to multiply the top equation by 2. That would make a positive 4y and a negative 4y. So when I add them, they'll cancel. But I can't just multiply one term by 2. I have to multiply the entire equation to keep it equal. So if I multiply the entire equation by 2, I'm going to get 10x plus 4y equals 32. I don't have to multiply anything to the bottom equation because my y's now are the same number but opposite. So this means I can go ahead and add the equations. So 10x and 3x makes 13x, the y's cancel, and this gives me 52. Divide both sides by 13, I'm going to get x equals 4. Still have to solve for y. You can choose the top or the bottom equation, it doesn't matter. In this case, I'm choosing the top. So I'm going to get 5 times x is 4 plus 2y equals 16. 5 times 4 is 20 plus 2y equals 16. Minus the 20 over, I'm going to get 2y equals negative 4. Divide by 2, y equals negative 2. And then your solution is x comma y, 4 comma negative 2. All right, for C, notice when you add these equations, I'm going to get x plus 7y. Neither variable canceled, which means I'm going to have to do some work. Notice I can't multiply one equation and get the variables to be opposite. So this is going to be multiplying both equations to make the variables the same number but opposite. So it doesn't matter which one you choose, but I'm noticing the x's are already opposite each other. So that means if I want them to have the same number, I'd have to multiply the top one by 3, that'll make 12x, and the bottom one by 4, that'll make a negative 12x. That way my x's will cancel. So multiplying the entire top equation by 3, I get 3 times 4x is 12x, 3 times 5y is 15y, and 3 times 35 is 105. For the bottom equation, multiply by 4. 4 times negative 3 is negative 12x. 4 times 2y is 8y equals 4 times negative 9 is negative 36. Now notice my x's are the same numbers but opposite. So when I add them, the x's cancel. And then I get my y's, 15y and 8y makes 23y. And then 105 and negative 36 makes 69. Divide both sides by 23, y equals 3. Notice I'm not done. I still have to plug it in to solve for x. So I'm going to plug it into the top one because there's no negatives, like the bottom one does. So that gives me 4 times, I don't know x, plus 5 times y is 3 equals 35. 5 times 3 is 15. To get x by itself, minus the 15 over, and then divide by 4. So my answer, x comma y, is 5, 3. Just kidding. Okay, you are up. What is the solution? Okay, there's a couple ways to solve this one. For this one, I went ahead and canceled the x's since they were opposite each other already. So I multiplied the top equation by 5, bottom equation by 3. Notice the x's are going to cancel. And then solving, I get negative 3 for y. I plugged it into the bottom equation because there was only this negative here. And that got me a negative 5. Remember to write it, x comma y. So negative 5, negative 3. Great job.